Welcome back to the Mechanics of Solids lecture series. In this series of videos, we're looking at examples of plane stress and stress transformations. The next example is based on a problem from Mechanics of Materials by Timothy Philpott, Wiley 3rd edition. We're given the plane stress state as shown and asked to determine the transform state considering a rotation to the inclined surface. That would be this surface right here. And then sketch the stresses on the transformed element. First thing I like to do is we need to figure out what the rotation angle theta is. So I will draw a little sketch of a wedge-shaped element with the inclined surface as identified. And I'll draw the normal to that surface, and that's going to be the n direction. And the rotation angle is the angle of theta of n relative to x. Okay? According to the geometry, this angle right here is 50 degrees. That means this angle up here would be 50 degrees. And the n forms a 90-degree angle with the inclined surface, so theta must be equal to 90 minus 50, or 40 degrees. However, we note that our sign convention says that a rotation in the clockwise direction is negative, so the rotation angle that we want to consider relative to our transformation equations is a negative 40 degrees. Let's summarize the stress state. We have a normal stress on the original element on the x surface acting inward, so sigma x is negative 2885. We have on the y face a stress acting outward, so sigma y is positive 1305. And finally, we have a shear stress acting in the negative direction on the positive x face. So we're going to interpret that as negative 2115. And these are all in units of psi. Okay, so now we have what we need to calculate the transform stresses. Start with sigma n equals sigma x plus sigma y over 2, or negative 2885. Plus 1305 over 2, plus sigma x minus sigma y, negative 2885 minus 1305 over 2, times cosine of 2 theta, which is negative 80 degrees, plus the tau xy, which is minus 2115, times sine of 2 theta, or sine of negative 80 degrees. This computes to 929 psi. That's sigma n. Okay, sigma t we can get from this equation right here. Sigma t is equal to sigma x plus sigma y, negative 2885 plus 1305 minus sigma t, or minus sigma n, minus 929 psi, and that computes to a negative 2509 psi. This one's going to be sigma t. And finally, tau nt equal to negative sigma x minus sigma y, which is negative 2885 minus 1305. Careful tracking of signs through these calculations. Divided by 2. Sine of negative 80 degrees, which is 2 theta, plus a tau xy, negative 2115, times cosine of 2 theta, or negative 80 degrees. And that computes to a negative 2430 psi for tau nt. Okay, so finally, we're to the last part of the problem, sketching the surface stresses on the transformed element. I'll start by drawing a little coordinate system. Here's the x direction, here's the rotated n direction, and I'll draw the transformed 2D element around that. This direction is the t direction. Sigma n, 929 psi, stress is acting outward since they're positive. 929 and 929 over here. Sigma t, negative 2509, I'll draw those ones acting inward because they're negative or compressive. Okay, and tau nt, negative 2430. So on the positive n face, I'm going to draw that in the downward negative direction. and adjust all the other arrows accordingly. 2430 and 2430. Okay? And to summarize, I'll just say the units are PSI for the whole thing. And so that is my sketch, and that concludes this example.